Video, I'm going to go through some area questions related to the quiz that I'm going to put up on my website. So I'm going to look at how to calculate the area of some different types of shapes, and then we're going to look at some simple solids and how to calculate the volume of them also. So first of all, the area, we're just looking at how much is inside these different shapes. So for this one here, rectangle, what you do is you just multiply the two sides. So for this case, you're going to multiply 5 by 4, 5 by 4, and I haven't actually put in a unit here, so we can assume that our unit is centimeters. So we're going to get 5 by 4, and that gives us 20 centimeters squared. And we put a square sign in here when it's an area. Our next one is a little bit different. In this example, they've given you one of the sides, they haven't given you the other side, and they've given you the area. So we need to use algebra to actually find out what's the missing side here. So again, we're going to multiply this side by this, and we get 5 by x is equal to our area which we are given, which is 30. So the next thing that we're going to do is we need to divide both of these sides by a number that will give us x by itself. So if we divide this by 5, 5 into 5 gives us 1. So divide that one by 5, divide this by 5, and if we go down another line, we'll get 5 into 5 gives us 1, and we just write that as x. You could write 1x, but it's typically just written as x on its own. And then 5 into 30 gives us 6. So we have an answer there of 6 centimeters for the side of our box there. Our next question is a square. So in this one here, and I've actually drawn in the extra side with it, so I've written down square, and we know that this is going to be 5, this will need to be 5 also. So there, what we have is 5 multiplied by 5. And let's just note, you don't have to write this down, but I'm just putting this in so because it has relevance later on. That's equal to 5 squared. 5 by 5 by 5 would be 5 to the power of 3, and so forth. So 5 squared is equal to 25. So we have an area here of 25 centimeters squared. Our next question, we're given two of our sides because it's a square. This side will be the same as this, and it's equal to x. So this side will be x also. So for this one, you're going to get x multiplied by x is equal to our area, which is 100 centimeters squared. So area of 100. X by x is equal to x squared. Now what we can do to the two of these different sides, we want to get x on its own. So we can take a square root of this side to find x. And if we take a square root of this side, we also need to take a square root of this side as well. So what we're going to be left with is x is equal to the square root of 100, which is equal to 10, because 10 by 10 is equal to 100. So it's 10 centimeters. Our next example is for a triangle. And for a triangle, if you want to think about it this way, see if I was to draw around this in green, like so, a triangle will take up half the area of the box that it fits into. Now this will even work if that part of your triangle is stretched out here, the same formula will work. But it's just because if you draw a triangle in there, it's actually cut the entire area, and that entire area there, it is cut it in half. So the formula for that will be half your height by your length here. So, or the base of your triangle by the height of the triangle, if you want to think about it that. So you can have a half one half of 10 multiplied by 20. And if you want, you can solve this straight out, put that into your calculator and do it. Or if you want to also write the formula like this, this is a way that I prefer to write it. 10 divided by 20 divided by 2. So that's another way of writing it. You can write the height by the base and then divide the whole lot by 2. If you do this, you can divide 2 into 10 and you'll get 5 by 20. So our next one is 5 by 20, and that's equal to 100. So we have an area here of 100 centimeters squared. Equally here, you could have just done this out as 200 and divided by 2, and you get 100 as well. So our next example then is going to be similar to some of our other ones where we're actually given the base. We're not given the base, we're given the height, but we are given the area. So for this one, we've got 8 multiplied by x and then divided by 2. So similar to our formula that we just had up here. So 8 by x and then divide that by 2 is equal to our area, which we're given. So our area is 12 centimeters squared. So what we're going to do is divide 2 into 8, and we get 4x is equal to 12. Then what can we divide both of these by just to get x on its own? Well, if we divide this by 4 and we divide this one by 4, we're going to get x is equal to 3. So we've 3 centimeters here. Our next question is going to deal with a circle. So for a circle, the formula for it to find the area is pi or squared. And pi is a set number. It's roughly equal to 3.14 plus another few digits after it. So we're given our radius, and we just sub that straight into our formula to find this. So we get pi or squared, which is equal to 5 squared by pi. That's equal to 25 pi. And if you put that into your calculator, you have 25 pi is equal to 78.54, roughly. To keep things simple from now on in the video, I'm actually just going to leave these as pi on it. So if I get an answer like that, I'm just going to say 25 pi rather than working out the decimal place. But if you do want to go into your calculator and work them out. Your next one, now this symbol here is a diameter of 15. Now a diameter is the whole width of the circle. So that means if I come from here to here, I check that length, that is 15. And I've no unit, but we can assume that's centimeters for this question. So what we'll say is if that's 15, that means my radius is equal to half of that, because that's half the distance across here from my radius. So my radius will be 7.5, which is half of 15. So my radius is going to be equal to 7.5. And again, we're going to put that into our equation. So pi r squared is equal to 7.5 squared and by pi. So 7.5 squared is 56.25. So we're going to say that's going to be equal to 56.25 pi. And then we need to put our units in here as well. So we're going to get centimeters squared. Our next question is a semicircle. So if you think about that circle that we looked at above us, if you were to, our answer there is the area of the whole circle. If you wanted to find a half circle, all you do is you divide that area by 2, because we're taking a whole circle and we're dividing it in half. So for this one, we can just put in our formula, pi r squared, and then because we're dealing with a semicircle, we can just divide it by 2, and that'll give us half the total area. So this is going to be equal to r squared, which is 6 squared pi divided by 2, which is equal to 36 pi divided by 2, which gives us 18 pi. Centimeters squared again. Our next example is not just going to divide it up into 2. It's going to divide it up by 120 degrees. So if you wanted to think about this example above it, that would be 100. If you think about it, there's full 360 degrees in a full circle. So that's 180 degrees off them 360. So 180. So what you've got there is you've got 180 over 360, which if you break that down, you can divide 180 into 180 goes once, and 180 into 360 goes twice. So that's why you get a half, and that's why we got a 2 up there. This example, we need to think what proportion is 120 off the full 360. So the formula for this, if you take this, we call this angle theta, like so. The formula for this is just to go theta. As you can see, theta would be 180 in this case, and this one is going to be 120 over 360 multiplied by pi or squared. And that will give us the answer for any one if you just take the angle there. So you can see in this particular example, we've got 120. 120 over 360 multiplied by pi, and what's or in this case? Or is 15, so 15 squared. We can go down, we can break this fraction down further. If I divide 120 into 360, I actually get 3, so it's a third of the overall thing. So 120 into 120 goes once, and 120 into 360 goes 3 times. So what we're going to get is this multiplied by pi to the power of 15 squared, which is 225. And if we divide 225 by 3, which is what's going to happen, we're going in here. Actually, I'll rewrite it here just so you can see this. If we multiply this across, we've got 1 by the top, so we get pi by 225 divided by 3. So 3 into 225 goes 75 times. So what we have here in our ending answer is 75 pi and then centimeters squared at the end. Our next example, we're going to look at combining different shapes. So for this one, what we've got is we've got a rectangle, which I've already shown how to find the area. And then we have a circle here as well. So what we're going to do is, a semicircle here. So what we're going to do is find the area of the rectangle, the area of the semicircle, and I'll just highlight this as 1. So we just know what it is. And this is area 2. And then we're just going to add the 2 of them together. So we'll find area 1 here. You're going to get 30 by 16. And that is going to be equal to 480. Area 2, remembering that this is a semicircle. So we can use our formula up here, or if we just remember that we're literally just taking a full circle and then dividing it by 2. So we're going to get pi or squared pi or squared divided by 2. So or in this case, what is or? We're not actually directly given it here, but we can work it out from our drawing. So this is 6. If this is 16, this has to be 16. So that means we've got a diameter of 16 for this circle. So that means the radius, which is half the diameter, and I can draw it in here, is 8. So for this one, we're going to get pi 8 squared divided by 2. So that's what we're going to get, 64 pi divided by 2, which gives us 32 pi. And again, we can just add in here centimeters squared on this one, because this will be centimeters squared and this will be centimeters squared also. And since we've got the two numbers together, just to simplify it up, I actually will multiply 32 by pi this time, just to get a more exact number for it. So 32 multiplied by pi is equal to 100, roughly 100.53. 100.53. So what we can do is we can write add the two of these together. So total will be my area 1 plus my area of 2, and that will be equal to 32 pi. Sorry, my mistake. That'll be equal to 480 plus 100.53. 480 plus 100.53. And this will give us for 580.53 centimeters squared. Our next example, we're going to look at two shapes combined. So this is going to be, again, so this is going to be two rectangles that are put together. So first of all, we're going to see, it's actually easy. It's drawn in for us, this part here, so we know where to divide it. Now, you could attempt this question. You could also equally divide it this direction and find this rectangle here. And you could also find this rectangle here separate. It's just a different way of answering the question, but I'll do it the way it's done out here with that dividing line in it. So first of all, we need to think about what's the size of our two shapes. So we're not actually given this length here, but can we work it out? Well, if this overall length is 20 and this is 8, this length here will have to be 20 minus 8. And that will give us 20 minus 8, which is 12. So we know this side is 12. So the area of this is going to be 12 by 8. And then this one here, we'll see we're also missing this side. Can we work that out? Yes, we can, because we look over here, we can see that's 18. 18 right down from the top. So we've got 18 minus 12, that distance there. So that gives us a distance of 6 centimeters. So let's find the area of 1 and the area of 2. So 1 is going to be 18 by 12. That is going to equal to 216. So that's 216 centimeters squared. Our next one, area 2, is going to be 6 multiplied by 8. Which is going to give us 48. So our total is going to be area 1, which we'll just call 1 like this, plus area 2, which is equal to 216, plus 48, which is equal to 264. And again, centimeters squared there. Our next example is going to be different. For these ones, we actually added an area on. For this one, you can see that there is an area that's been cut out of it. And this is I haven't mentioned it in the question, but you might be able to see that this is actually just a quarter circle. So first of all, we're going to find the large area here, the total square area, and then we're going to subtract this smaller area right here. And when we take this away, this little chunk out of it, we're going to find the area of this part here. So we'll find the square first, because that's easy. So we'll call that area 1. And we'll call this area 2. So to find the square, all you have to do is area 1 is 10 by 10. Let's call it 10 squared, same thing. And that's 100. So that's 100 centimeters squared. And then we're going to find area 2. So area 2 is going to be, now, this is a quarter. If you think about it, we have the whole circle here. This is just a quarter of it. So all we do is find the whole circle area and divide it by 4. So we're going to find the whole circle area, which is pi r squared, and divide that by 4. So what we're going to do is here is we're going to have pi, and then or you can see the radius here is given as 5. So 5 squared divided by 2, and that's going to equal to 25 pi divided by 2, which is equal to 12.5 pi. And again, I'm going to actually just multiply that out, because we'll be putting our two different symbols there together. So we get roughly 39.27, rounded up to 2 decimal places. 39.27 centimeters squared. So what we're going to do is our total is going to be area 1, the whole area here of this big square. So we're going to get 1 minus area of 2. And that's going to be equal to 100 minus, 100 minus 39.27, which gives us 60.73. So just drag this down. That gives us equals 60.73, and that is centimeters squared again. So we can assume for all of these different questions I've just picked centimeters, but obviously this could be meters or this could be millimeters as well. So the next one, and I'll just rub some of the stuff out here from top so we've space to write in. So our next one, we've got this shape, and we need to think about how we're going to divide it up. So maybe we draw something like that triangle, and then we'd have to make that into another triangle. So we'd have 3 triangles. That could be a little bit complicated. So maybe there's an easier way to do it. So actually what we can do here is just draw a line straight across here. That is an easier way of dividing up. So there's different ways you can divide these up, so you need to just find the easiest one of them ways. Now, if we look at this one, we can see we're not given the base of our triangle, which we're going to need to work out this area, but we're given this distance at the bottom, which is basically the base distance, because that is equal to the same thing. So that's equal to 8 centimeters. So let's find out. What we're going to do in this one is we're going to find our triangle, and call that area 1. We're going to find our rectangle, that's area 2, and then we're going to add the 2 of them together. So to get your triangle, what you're going to do, and that's going to be 1, we're going to say 3 multiplied by 8, and then divide that by 2. So that's your height by your base, and divide the whole lot by 2. So you could multiply this out, 3 by 8, which would give you 24, divided by 2. That gives you 12, and that'd be fine to do it that way. But maybe I'll do it this way. 2 into 8 goes 4 times. So we get 3 multiplied by 4, which gives us 12. So that's going to give us 12 centimeters squared. And then our rectangle, which is 2, it's going to be very simple. All we have here is we've got 8 by 10. So 8 multiplied by 10, which is equal to 80. So our total area is going to be 80 plus 12, which gives us a total area of 92 centimeters squared. Our next question, similar to the one we were looking at with our circle, is going to involve an area that is subtracted from another area. So in this one, we're going to take this little triangular section right here, this section, and we're going to subtract this bit out of the whole area. So we'll call this area 2, just because that's the one getting subtracted. And we'll call this area 1 then. So we're going to be taking the second area from the first area. So let's find this first of all. So 40 by 30 is going to give us area 1, 40 by 30, which gives us 1,200 centimeters squared. Then area 2, which is going to be the base. And again, we're not given it, but we can see if this is 30, this needs to be 30. And this triangle is upside down. I'll just draw this out just so you can see it's basically the same thing. I know it's called the height, even though it's going down low there. So if we just flip that triangle upside down, it'll look like this. So then we're just dealing with our height. Put in a different pen here. So we're just dealing with that height by that base. So our height is 10. Maybe you can see that straight away, but just in case you can't, I'm putting it in. So it's just the same as that, 10 by 30. So similar to the other questions we were doing earlier. So this one here, we're going to get 10 by 30, and we're going to divide that by 2. So we can divide 2 into 10, goes 5 times, so we get 5 multiplied by 30, which gives us 150 centimeters squared. And then the total will be 1,200 minus 150. So maybe not realistic to the diagram I've drawn here, but we'll work it out all the same. 1,200 minus 150. And that gives us 1,050 centimeters squared. Now, in the next question, we're going to start looking at volume. Let me just rub this out here so I can have a little bit more space below. So if we go down here, we're going to be finding the volume of this cube. So the volume for the shapes, at least the shapes we're going to look at, will be reasonably simple. It's just a matter, if you imagine this is a rectangle and it's been extruded up. So it's, if you look at other parts of my website, there might be good illustrations that'll show that. But basically, this is the 2D shape. And if you could imagine, it's been basically stacked on top of each other a number of times. So if you had, say if you just took this and that was 1 centimeter. What you'd have is 4 by 10, which would give you 40 by 1. So your area here would be 4 by 10 by the height, which is 1. So that's all you're adding in. That's the area of the top section and then the height. And that would give you 40 centimeters cubed. So we'll take this one. This is a height of 20. So so for this particular example, we're going to have 4 by 10. Volume is equal to 4 by 10 by the height, which is 20. So what we're going to get is 40 by 20, which is 8,000, I think. 20, which is, 800, my mistake. 800. So it's 800 centimeters. And then for this time, because it is a volume, you put in a cube sign. So square is for area, and then cubed is for volume. So the next shape is going to be the same. So all the ones we're looking at are all going to be just calculate the cross section. No matter how complicated looking the cross section is, even if you got something like this, if you got any sort of a complicated shape like that, like this. As long as you can find that area, and as long as there's nothing, if there was little bumps or anything like this would completely change the question. But for the ones we're dealing with, we won't be doing that. But if for these ones, if you could just find the area of this, and all you have to do is then just multiply by the height. That's the only difference to find in the area questions. And so for the next one, all we have to do is find the area of this circle, which you know how to do, and then multiply it by 25. So for that one, you're going to get pi or squared. I won't write it out this time. We'll just say 5 squared by pi. And then we're going to multiply that by the height, 25. So we're going to get 25 pi by 25 by 25. And then we can actually just leave the pi there at the very end. So we just get 25 by 25, which gives us 625 and pi centimeters cubed. Our next one, going to follow the same process, which you know how to do. So you're going to do a triangle. So you're going to have a base of 6, height of 3, divided by 2 to find your triangle. And then you're just going to find that you found, once you do that, you found the area of this, and then you just multiply it by the height. So you're going to get here, the area of the triangle is 3 by 6 divided by 2, which gives us 3 by 3, which gives us 9. Sorry, I'll just put this in as well. And that overall thing multiplied by my height, which is 10. So what we're going to have here is 9 by 10. Simplify that down, it becomes 9 by 10, and that gives us 90 centimeters cubed. Our next one is going to look at an example like what we had down earlier, where we're going to actually have a combined shape. So we're going to have something with a combined cross section here. So I'll just make this picture a little bit smaller. Actually, I'll leave it big because I need to draw on top of it. So for this one here, we need to find, so we're going to divide this into two. So we can divide it across here, or we could do a line here. So I'll just pick a line coming down this direction to divide. So we're going to have this area here as one of the areas we're going to find, and we're going to add that to the area that I have here. So drawing our line to divide it again, sorry, took it out last time, and we're going to find the area of this. This will be 50 by 25, and then we need to find this small little distance here. And is there any way we can work it out? Well, we can see that this is 25 across. This is an overall of 40. So 40 minus 25 will give us this little distance here, which is 15. So you can see 15 plus 25 is equal to 40, the total length. So area 1 and area 2. So to get the total, we're going to have 1 plus 2. So 1 is going to be 50 by 25, which is equal to 1,250. Area 2 is going to be equal to 15 by 15, so 15 squared, which is equal to 225. So the total area is equal to 1250 plus 225, which is equal to 1,475 centimeters squared. Now we want to find them. So we found this cross section area. We found all this area here. Now we need to multiply it by our height coming down. So what we do is we take our volume, is going to be our area by our height, which is going to be, let's put our height first, 70 multiplied by 1,475, which is going to give us 103,250. So 103,250 centimeters, and then we'd square for area, and then if you remember, cubed for volume. Our next, and it's the last of the examples, we'll look with combined areas. So our next one is going to be this figure here, which you can see is going to be a square. And this isn't too clear from the diagram. You can see they're two separate shapes. So this is a triangle, this is a square, and we have them drawn as a cross section up here. So let's find our triangle first. So this is going to be 6 along here because it's 6 at the bottom. So we'll just put that in. So find our triangle first. So we'll call that 1, and we'll call the rectangle 2. So we're going to find our rectangle, find our triangle area, and then we're going to add the two of them together. So triangle 1 is going to be 5 by 6 divided by 2, which is going to be equal to 15 centimeters squared. Area 2 is going to be 10 by 6, which is equal to 60 centimeters squared. The total will be 1 area. So the total area, not the volume yet, is going to be 60 plus 15. So that's 1 plus 2. Area 1 plus area 2, which is going to give us 75 centimeters squared. So then we can find our volume is going to be it's going to be this, which is our cross-section area multiplied by our height. So we're going to get 75 multiplied by 20, which is going to give us 1,500, I think, and I'll just double check it here. 1,500. And then this time, this is our volume, so that's centimeters cubed. So let's look at, just to finish up, I've got 2 different practical examples of areas where would you use this. So imagine if somebody had a swimming pool, and I haven't written in the question here, but when you do the revision quiz, it'll be written in. So we've got a swimming pool, and we want to find out how much water, what volume of water would we need to fill this up. So if you wanted to work out how much it was going to cost you maybe to run the swimming pool, you'd have to do this. So first of all, we're going to have our square at the top here, and then we've got our depth. So all we do is we find the area of the top, which is going to be 8 by 4, 8 by 4, and then multiply that by 3, which is our height. You could also do it, if you wanted to think about it with this area, you could have 3 by 4 by 8, you'd get the same answer. It's just a different way of doing it. So 8 by 4 by 3 gives us 96. And just in case you're confused with some of my symbols earlier, see sometimes I'm using the bracket up here, and this is the exact same as writing 8 bracket 4 bracket 3. It's just sometimes I'll use these symbols, sometimes I use these. Sometimes when you're doing algebra, it's handier to have brackets because the multiplication symbol can get mixed up with x's, which are commonly used in algebra. So the very last example we're going to look at, and it'll be slightly more complicated this time because instead of just finding the volume, we're going to be given the volume for this question. And then we're going to have to find the height. So imagine if there's a manufacturer and they're making a type of beverage can, and they find that it has to be the diameter of the circle at the top has to be 6 centimeters because they want it to be a certain size to fit in a shelf or to fit in a cup holder. The volume that they want is 90 pi. What height should they make the can to achieve a volume of that, to hold that amount of liquid? So let's look here, and there could be something that could catch out. Remember, this is circle diameter, not radius. So if the diameter is 6, that means the radius is half of that. So the radius is going to be 6 divided by 2, which is 3. So find the circle area is going to be, we'll put in a formula for our volume. So our volume is going to be the area of this times the height. which we've represented as X. If it was easier for you, you could also represent that as H. It doesn't matter what letter you use. So for that one, we'd go pi or squared. So our or squared is 3 squared. So actually, I'll just write out the formula. So pi or squared H. That's the total volume for a cylinder. That's the formula for its volume. So the pi or squared H is equal to what we're given is, we're given 90 pi. So let's just fill our symbols into that. So what we're going to have is pi or squared, which is 3 squared H. Sorry, and I shouldn't have put that in as H. I'm going to change that to, I'll leave it as H there, but we'll put it as X here. Doesn't matter. I could have left it as H, found the height of H, and I'd still know what that is. It's just using a different letter. Is equal to 90 pi. So what we can do is we can actually divide both sides by pi, because pi into this goes once, pi into this goes once. So we'll do that anyways, and we can eliminate our pi's out. We can eliminate our pi's out of this question. So we can cancel pi on this side. Is there anything else we can do? Well, let's just multiply out this this 3 squared. So we get 9x is equal to 90. What can we divide this by to get x on its own? We divide that by 9. So if you divide that by 9, and if you divide anything on one side in algebra by a number, you have to do the same to the other. So you can divide that by 9 as well. So in that one, we're going to have 9 into 9 goes once, which gives us x. If you wanted to think about it like that, it could be 1x, but it's typically just written as x. 9 into 90 goes 10. So what we have here is we have a height of 10 centimeters for our can. So that's everything from this video. So you can go ahead now and you can answer the self-correcting quiz and attempt some of these questions for yourself.